So today I'll be talking about automating FedRAMP security compliance with Terraform. So as Pato said, the compliance part is probably the boring part. The Terraform is the fun part. But in order to achieve cloud compliance, using automation like Terraform is a really easy way to get things done. So this is essentially what the talk is about. And let's go ahead and put ourselves into a situation to kind of get ourselves acquainted with compliance. So imagine that you're an engineer and your company now wants to do business with the US government. That means that you have to bring your cloud environment to the standards that the US government is expecting in order for you to be able to do anything with them. So you get a mandate from one of your managers that you need to get your cloud environments ready for what's called FedRAMP. You do some research and you ask yourself, well, what is FedRAMP? You find out that FedRAMP is the Federal Risk and Authorization Management Program. It is a government program that is coordinated by 6 different government offices. So you have the Executive Office of the President, the CIO Council, NIST, the U.S. Department of Homeland Security, the Department of Defense, and the GSA that kind of all coordinate that program. So it's pretty complicated. There's a lot of jargon associated with FedRAMP. One of it is an ATO, and that's the whole reason that you're going into FedRAMP is to get that ATO. An ATO is called an authority to operate. That's basically what's necessary for you to do business with the US government in the cloud environment. And this cloud environment can be like a SaaS, which is a software as a service, a PaaS, which is a platform as a service. Eat the mic. Okay. And basically, it helps you with sales enablement for your applications that are in the cloud. So as with any kind of government program, it's a very cumbersome process. The image at the slide that's on right now shows the typical 4-step process, but that's actually a whole bunch of sub-processes that are under the 4 steps. So basically, it's a very involved process, and it comes with an extensive control set. So basically, there's 325 different controls for FedRAMP Moderate. And that is what we're going to be talking about today is FedRAMP Moderate. There's also a FedRAMP High, which has like 100 more controls, and FedRAMP Low, which has a little bit less. And FedRAMP also requires many different pages of documentation. And I'll give some advice on how you can actually automate that as well. So it's an understatement to say that FedRAMP compliant controls in the cloud can be overwhelming because this is a very cumbersome process. It's very involved. And luckily, though, we do have some automation at our disposal that'll be able to help us out. So this automation is infrastructure as code, and Terraform is what we're talking about today. Basically, the flow goes that compliance controls can be mapped to Terraform resources. Terraform resources can be packaged into modules. And then these Terraform modules can be utilized to create building blocks for your compliance program. Basically, by combining different Terraform modules, you can create secure and compliant infrastructure for the cloud at ease, at scale. So in other words, Terraform makes compliance easy. It's easy. You have to do the initial setup of Terraform, your Terraform modules, but I will walk you through the process of how you can map these different controls to the resources and so on. This is the typical kind of approach that I take whenever automating compliance programs and so on. So I think now would be a good time to kind of formally introduce myself. So I'm Eric. I have about a decade of experience with cloud DevOps and security engineering. I've led infrastructure security programs. I am a DevSecOps practitioner, so I like to automate a whole bunch of things, especially security controls in a DevOps way. Both AWS and GCP certified, including the security specialties. I'm currently work at ScaleSec, which is a cloud security consultancy where we specialize in dev and compliance. So I've worked with a wide variety of businesses from startups to Fortune 500 companies in automating their compliance programs. My Twitter, GitHub, and LinkedIn is also there if you want to reach out for me with anything like that. So what I want to do today is outline some challenges that are associated with compliance in the cloud, particularly FedRAMP. So we'll talk about what those challenges are and why it makes compliance a scary thing sometimes. Then we will see how framework controls can be mapped to Terraform resources. So basically, I'll walk through how we've derived those controls, how we then map them to different Terraform resources. And then finally, we'll see how we can combine those Terraform resources into easy to use modular code that can meet your compliance requirements. So full disclosure, Terraform is only going to get you about 75 to 85% to a full FedRAMP compliance. You definitely need to use a combination of tools in order to get the full set. Luckily, we have HashiCorp Vault and Packer and Console. Unfortunately, I won't be going in depth with those tools today, but just know you can use Vault for access. For instance, brokering SSH access into your cloud environments for access control. Vault's also great for secrets management, which is also something that FedRAMP auditors like to look for. HashiCorp Packer can be used to create compliant AMIs with all the security controls baked in. HashiCorp Console is very great with service mesh and with other things like mutual TLS and so on. And then Terraform Enterprise, it makes it even better. So basically with Terraform Enterprise, you can leverage Sentinel, which can help you enforce compliance at different levels. So you can have Sentinel kind of just advise and say, well, you know, your Terraform code isn't compliant, but I'm going to allow it to go. Or you can actually have it block any changes before it happens to your cloud infrastructure. Again, these can be talks in themselves, but just full disclosure that Terraform is getting you most of the way there, but not all the way there. So there's some challenges with compliance that I mentioned before. Let's go ahead and start outlining them. The first thing is companies of all sizes have issues with security compliance. Again, I've seen startups, I've seen huge corporations and companies kind of work with their security compliance, and they have a whole wealth of different issues. So if you ever feel like you're having issues with security and stuff, you're definitely not alone. If you're not having issues, you're probably having issues you just don't know about. Compliance can be seen as a hurdle to development teams. So basically, compliance can be seen as something that is slowing down development. It can be seen as that extra gatekeeper that's keeping you from releasing your new product, or just a checkbox that needs to be done before you're compliant, before you can actually do anything in production and so on. This can be addressed with education. You just need to know that, walk through your developers, right, and say, hey, compliance doesn't necessarily need to be so cumbersome and so hurtful. You can actually use infrastructure as code to automate a lot of this stuff and actually make it easy to be compliant in your cloud infrastructure. So if you get that, you still see some anti-patterns that emerge. For instance, point and click for compliance. So that's going into your console, AWS or GCP console or Azure console, whatever it may be, and just simply going in there, going to EC2 or whatever it may be, checking the boxes for encryption and saying, oh, we're compliant. That's great. Well, issues with that is it's not scalable. It's more work. You can be inconsistent. Humans are prone to error. Computers tend to handle automation pretty well. So that doesn't necessarily work great for a robust compliance program. And then you have mutable infrastructure. So that's something that Terraform does very well, is the immutable type of infrastructure. The main issue with this being configuration drift. And again, that could be a whole subject in itself. But using immutable infrastructure with Terraform really is great for that. And then, of course, I mentioned documentation. I do want to kind of outline how that can be a challenge as well. So if you're doing FedRAMP compliance, your documentation could be well over 1,000 pages. That is insane. Your system security plan and SSP, again, jargon, I told you it would be on here. Just know those are your controls for your cloud environment. That itself is mandated by the federal government to have a specific format. It's actually a CSV. I mean, it's not too complicated, but it can be automated. And I do have a link up here for FedRAMP Up, which kind of automates like 90% of your documentation by taking an asset of your cloud inventory and the controls associated with them. It puts them in the right format. And then you have other policies like your information security policies, your privacy impact assessments, so on and so on. All that's outlined in FedRAMP.gov website, where you can actually go through the process of developing a system security plan. And so a cool thing about Terraform is that it can actually be your documentation too. you have to get the right auditor, right? So this is why it's sometimes. Some auditors come in and they're like, I don't want to see code. I don't want to see code at all. And that's when you actually have to supply them with the spreadsheets, when you have to supply them with the docs. But if you get the right ones, they can actually look into your code, and I'll do this in a kind of a demo type of way later on. And the code can speak for itself. The code says, hey, I've done encrypted volumes. I've used VPC endpoints to go into my S3 buckets and so on. Those types of controls are documented in your infrastructure as code, and it can be supplied as documentation. So that's another benefit to using Terraform for your compliance. And so we're getting closer to mapping compliance with code. Again, it's important to get teams educated on how compliance doesn't need to be scary, how to do proper infrastructure as code, how to not do those anti-patterns we just talked about, and so on. And we also have some automation and guidance on docs, right? With things like FedRAMP up and maybe even using your infrastructure as code as your documentation. And now it's time for us to identify what controls do we need for our situation. So do we need to codify like all 300 whatever controls for FedRAMP in Terraform, or is there a way that we can bring that number down? So you got to ask yourself a few questions, like what services are in scope? This is typically, so one thing about FedRAMP is that your cloud providers that you're using also have to go through a FedRAMP ATO, right? Authority to operate. They have to go through the same process that you're going through for your company to actually be FedRAMP compliant and do business with the government. And they do this one service at a time. So it'd be like S3 would get it one day and EC2 would get it another day and so on. So you got to figure out what services have actually passed the FedRAMP ATO. And then what controls are inherited by the cloud provider. So this is where we talk about the shared responsibility model, right? When you're using a public cloud provider, a lot of things are actually taken care of for you, like the hardware. You don't have to do maintenance on that. You don't have to worry too much about some of the lower level architecture of your cloud environment and so on. So that's basically the questions that you would ask. And so let's talk about for what's in scope. So for CSPs, which are cloud service providers, only a subset of services are authorized to be used with FedRAMP, just like I mentioned earlier. And for FedRAMP Monitor on AWS, I have a list there of the following that can't be used, but the actual source of truth is a table like this. And again, there's the link on there where you can see what services are in scope for FedRAMP. And you can also see the other tabs there as well. So you don't have to use this just for FedRAMP compliance. You can use it for other things too, like SOC and PCI and ISO and so on. So that's interesting about compliance, and it will help us actually just kind of scope down what we need to write. So we write less code, which makes things simpler, which makes security simpler, which makes it more robust, in my opinion. So that's what we get. And then with inherited FedRAMP controls, I've already done the math for you. Well, kind of not done the math, but 99 is what those numbers add up to as the number of controls that you inherit for your FedRAMP compliance. So that deals with your maintenance, media protection, and your physical and environmental protection. And there's a diagram for AWS, and I'm sorry, these slides are AWS specific right now, but you can get these similar type of things for other clouds as well, like GCP and Azure and so on, to see what responsibility is it of the cloud provider to provide, and what security controls do you have to provide as the customer. So you've already knocked out 99, right? Now you're down to maybe like 200 or something. And then if you have some services that are not in scope and stuff like that, then you have even less that you really have to worry about. There's other things too, like where does your boundary lie and so on. I won't get into details about that because this isn't a compliance talk, but basically you have less to do because you've done that legwork up front. All right, great. So what's left over is controls that could be handled with Terraform. So we'll look at a few services just as an example for the talk. And then the question that I always get is, okay, so you got all these services, you got all these controls. How do you actually prioritize like what to do? What controls are important in my security environment? What do I need to secure first? So you can use a risk-based approach. So you could do the basic math. What is the likelihood of a data breach? And then what would the impact of that data breach be? You multiply those together, and that's your risk, essentially. So if you implement the controls with your highest risk first, maybe something has a high likelihood and has a high impact, that's going to be a very high risk. Those would be the ones you want to target first. And then you can also just start with best practices. So what makes sense whenever you're thinking about securing your cloud environment? That would be your list of best practices, and it usually culminates into something like this. So a table, basically that whole right-hand side are those best practices that you're thinking about whenever doing compliance. So you're like saying, oh yeah, I want an S3 bucket policy. I don't want it to be public. I want it to be a private bucket. And so you'd want to make sure that is defined. You want to ensure that versioning on your bucket is enabled, S3 bucket logging, lifecycle rules, bucket replication, and server-side encryption is enabled. And each one of those maps to FedRAMP controls. So just by you doing a simple thought exercise in maybe like 5 minutes, you're already knocking out several different controls for that service. So you're from the beginning just like mapping them out and getting ready to figure out what you need to codify. This is what we're heading into. Same thing for like VPC. Again, this is not an exhaustive list. This is just an excerpt of what could be automated essentially using Terraform, but you can have controls on your VPC endpoints, ingress and egress for your ACLs, that kind of stuff. So just security things that you're thinking about whenever doing compliance for AWS. So let's go ahead and start looking at code, shall we? So basically you have that table, you have your control set, you have your FedRAMP controls that are mapped to it, and then you come out and you say, okay, I'm going to write some code, and I'm going to go ahead and basically translate these FedRAMP controls into Terraform. Walking through it step by step, you can set a bucket policy in your Terraform file. You can set bucket versioning, and you want that to be enabled for sure. You could set your logging with a target bucket, which that would be the bucket name. Replication configuration, which is cut off here just because it would be very tiny on this slide, but that satisfies some FedRAMP controls, and you'd want to specify that in your bucket. Server-side encryption configuration, that's also something that you want to specify in your bucket. Lifecycle rules, so 90 days, you want to keep that ready and everything. That's actually the control. And then 365 days, so after a year, you want to keep offline retention. That's just a little nuance with FedRAMP, but it is a control that you can implement pretty easily with Terraform. Great. So basically what we did there is in this code, right? We have created a resource that is FedRAMP compliant. You finally got that one resource. That's great. How do we use this resource at scale now? Well, you guys are probably already thinking, if you're seasoned Terraform users, that you want to encapsulate this into a module. So why modules? We want to encapsulate multiple security controls into a single construct. Basically, whenever I have an S3 bucket and I want to use that in my environment, and I know my environment needs to be FedRAMPed, right? It needs to be available for the US government to use. Then now that I have a module with a FedRAMPed kind of resource, that module now encapsulates all those security controls into a single construct, helping with reusability and reducing work. It's essentially what you're doing there. You can use versioning to make it easy to update at scale without breaking things. So you would want to tag your modules to a specific version. And for FedRAMP, so it'll be easier for you to keep your ATO, your authority to operate, right? If continuous monitoring shows something that needs updated. So part of keeping your authority is to continuously monitor it either on a basis. And then if you see something that's out of compliance, you can simply create a new version of your module and then update it, which will update your infrastructure. And what it looks like is with modules, you basically create that template as a one-time build, and that's your security baseline for that module. It only needs to be defined once, so you don't repeat yourself. You keep your code dry. You template once, and then you build, assess, and authorize afterwards. So for each subsequent project after that one-time build, you have savings because you've encapsulated stuff in the Terraform module. And taking it a step further, you can manage your application infrastructure that's built from these curated, hardened building blocks, so to speak, which would be the modules. These modules then can be used with together, basically. You use the modules together, and that creates your Terraform templates, which are applications that use those modules as your hardened building blocks. So you combine like IAM and a bucket and a volume, and that would create an application. That would be something that then you can deploy into your cloud, and you just reuse these templates to deploy your applications across multiple environments, multiple regions. So that's where the scalability comes in. And you can see from the previous 2 slides that you're saving work and you're making your infrastructure more scalable, all while making it very secure and essentially enabling business to happen, because now you have something that can be sold to the federal government in this case, but in other compliance cases, you may have a different target audience and so on. So it's like bridging the gap between engineering, security, sales, and all that kind of stuff. And so I'm going to walk through a quick example of, and it's a very simple example of just an EC2 instance that's using a VPC endpoint to access an S3 bucket. The S3 module, we've already kind of went over the controls for it, so I won't go over it again, but basically we'll see some of those access controls happening. VPC module, and again, not an extensive list, but it could use the VPC endpoint. It'll use ACLs for external information services. And then your EC2 module, which can use like security groups, boundary protection, encryption for system and communications protection, and so on. So yeah, let's get to it. All right, I don't know if you can see my code.
Hey, Eric, we cannot see your code. We just see the slides. Now we see your code. Perfect.
Awesome. Great. So this is the main.tf where we declare our VPC, we declare our IAM replication role, VPC endpoint, EC2 instance, and an S3 bucket. A very simple example again, in a more robust infrastructure situation, you'd probably have a lot more variables going in there. You'd probably supply some values for namespaces and tags and so on. But this is just a very basic part of it. And then if you look at the project structure, I'm going to go through the S3 module, and we're a little bit over time, so I'm just going to go over through this module and kind of show you how it works. So basically, when you have an S3 module, you can have different controls that are satisfied by there. So this is similar to what we walked through before. It's a little more fleshed out because we have a policy that's being there, but you can actually put in your comments what FedRAMP controls you're satisfying, and from there, that's what the auditors can see in plain English what you're actually doing. You're creating your controls and a description for that control that you're doing for each block of code that you're implementing as a control. Same for versioning, same for logging, and again, in plain English, you're spelling out what you're doing, and then replication configuration, server-side encryption configuration, the controls that are satisfying it, the control description for that, and so on, and that good old lifecycle rule that we talked about before. In this S3 module, I've also created a destination bucket for replication just to make it a little bit easier. That way, whenever you declare an S3 bucket, you already know it's being replicated somewhere to another bucket that would essentially just be that bucket, a copy of that bucket. And then from there, we have a S3 bucket, which is the logging bucket, and that would be logging all of the access that happens in your S3 bucket. This control can actually be satisfied by using CloudTrail logs or something like that, but you can also use an S3 bucket to log to as well. All right. So that's, I wanted to show a lot more on that, but we are running over, so I don't want to go too far on. So in summary, compliance can be a struggle for organization of many sizes, and we went through some of the reasons why that can be a struggle. But with proper mapping of controls, you can implement those as Terraform resources. Then you can use the Terraform resources, encapsulate them as Terraform modules that could then be used as building blocks to put together the pieces and create a better picture for your cloud compliance automation program. Some key takeaways, Terraform can make compliance easy. I mean, that's basically the main kind of goal here is to make compliance easy, and we can do so with infrastructure as code. You can actually work with compliance teams and use modules to create secure infrastructure. And if you're a cloud engineer with that mandate to implement something like FedRAMP controls with AWS, you can now tackle the problem with confidence using Terraform. Now questions, and here's all my contact information. Thank you, everybody.